All right, hello, pre-calculus. Here we are with a review of the practice test for 6.4 to 6.6 so that you can get help if you need it, so you can do really well on your test this week. So here we go. Number one starts off pretty difficult. We're going to find a value for which this f of t has a local max within this specific interval. So a couple of things I would think about before I even started this problem, just to get my head around it, is I'm looking for a local maximum. Okay, so these are going to occur in the inside of the graph, if you will, in the neighborhood of the graph, not on the endpoints. You have to actually see for a maximum, you have to see it changing from increasing to decreasing. So we're going to be, looking at the interior, if you will. Here, I'll speak to that a little more in just a second. I'm going to think about sine, and sine is going to start at the midline. It goes, it increases, and then it decreases, and then it increases. So a maximum is going to occur, right here when it goes from increasing to decreasing. That's going to be for the parent function of sine. That's at the for sine, that's going to be at the quarter period point. So I'm going to be looking for that quarter period first, and then I'm just going to make sure, due to the transformations, that it doesn't occur again. So a lot to kind of think about on this problem. So vertical shifts here. This is an amplitude of 2. There's no, this is a vertical stretch of 2. Vertical shift is none. So the vertical transformations, you have a vertical stretch of 2 and no vertical shift back here. So I knew I'm going to go to 2 and negative 2. So I know my maximum value is going to be in terms of y. It's going to be 2. But this wants to know where it happens. For what values of t? So where does this happen? Where am I going to hit 2? So that's the question that we're tasked with finding. All right, so let's factor, which it told us to do. It doesn't have to tell us to do that. We should do that anyway. And so when I factor a 2 out of pi over 3, you're just dividing. When you factor, you divide it out. So 2t over 2, is t. And then pi over 3 over 2. The 2 just is also in the denominator, so that's pi over 6. Okay, so I'm going to have a period change and a phase shift. So I'm going to need to, both of those are going to affect where this maximum occurs. Okay, so chart time. We'll just start at 2t. So we need our period, because we're going to half it and quarter it. And so our period is computed by doing 2 pi over b, and that's your b value. So this has a period of pi. So on our chart, we're going to go from 0 to pi. We're going to do half that, quarter that, and 3/4 of that. All right, so this is, I'm going to have a max here, period. That's the quarter point here. And that's going to be a maximum because this sign is opening, from the midline, it's opening up. All right, so now we've got to phase shift it. So our phase shift here is a left pi over 6. So you can write pi over 6 here, but remember to go left, or I like to just go ahead and write minus pi over 6. All right, so 0 is going to shift to negative pi over 6. You're going to have to do some fraction work here, guys. I'm not going to do that on the video. So pi over 4 minus pi over 6, you're going to get pi over 12. Okay, so, that's going to be a max. That's going to be a max right there at pi over 12. And as we said before, that's going to be at 2 on our y's. Okay, so pi over 2 minus that pi over 6, that gets us at pi over 3. 3 pi over 4 minus pi over 6 gets you at 7 pi over 12. And here at pi, we're going to minus pi over 6. We're going to do 5 pi over 6. And that's going to be one period right there. So, if you're looking at, 2 sine of t, all right, midline, max, midline, min, midline. Okay, so, I'm feeling like perhaps we could just answer the question right here. And maybe that's it, maybe not. We just have to be safe. So if you look over here, I'm going to be looking at this line right here. I'm going to be graphing this for the t and this for the y. And so this isn't quite at pi. I mean, it's almost at pi, but it's not quite at pi. So this goes from 0 to pi. So I want to, this is going to be heading on the up and up again. So am I going to reach another max here? This is going to be a 2. So I just need to make sure that I want to go one more spot over here. So I want to add, if I went one more pi over 4, that would be 5 pi over 4 would be at 2. And if I take that 5 pi over 4 and back it up by that pi over 6 here, I'm going to be at 13 pi over 12. Okay, so what this tells me is that 13 pi over 12 is bigger than pi, so this indeed is going to be another maximum, but it's not in the interval that the problem is having us look in. All right, so let's go ahead and finish the graph then. Whoops, bumped that. And so, the graph, we're starting at negative pi over 6, pi over 6. Nope, sorry, pi over 12, my bad. Pi over 12 is next. And then pi over 3. And then 7 pi over 12. And then 5 pi over 6. All right, so there we go. There's my max. Back to the midline, down at negative 2. And there's your 1 period for sine. Okay, so we're not quite at this pi here. Pi would be pretty soon, but it's not quite at the max. All right, so this then indeed is the answer, and so this is for t equal to pi over 12. That's your answer. Okay, so this is a max. This right here is not a max. That's an endpoint, and a local max or min occurs in the interior. Okay, in the inside or in the neighborhood, not on the endpoints. This is not max or min, and this is not as well. You need to be able to see the increase to the decrease, and since we stopped the problem here, we can't see the decrease, so this is the only feasible answer. All right, so that was a long one. Wow, 7 minutes on that problem. I think I'll do this in pages, because it's going to be awfully long if I don't. All right, which of the following statements is false about the graph of tan of t? All right, so let's just think about that super quick. We've got these asymptotes here, just really super rough. There's tan of t, okay? Negative pi over 2, so on and so forth. It has no sharp corners. That's true. I don't see any sharp corners here. A sharp corner would be like absolute value would be a sharp corner. So this is good. It crosses the horizontal axis more than once. Well, this is only 1 period, so you're gonna have more of these. If you've probably on the TI, we've showed that. So that's true. It has a horizontal asymptote. Has a vertical asymptote. So it looks like this is going to be a false, but let's just check. Periodic, absolutely it's periodic, and it has no amplitude, and those are true. So this is C. Okay. A cosine function with amplitude, of 4 has a maximum value of 3. Its minimum value is, okay, you could probably use your common sense and think through this, but I'm going to do it with algebra. And so remember, amplitude is 1/2 max minus min, and amplitude is 4, and the max is 3 minus min. So times it by 2, that's 8, is equal to 3 minus the min. Let's throw the min over here and the 8 over here. And this is going to have a minimum of -5. All right, on the interval 0 to 8 pi, give the ordered pair for the local minimum of this cosecant. Okay, so this is kind of similar to number 1. So cosecant is going to go with sine. It's going to be sine, so I'm going to think about that. And so if I was thinking about the minimum for sine, a regular sine that's opening, positive, the minimum of sine would be, at this 3/4 of a mark. But, cosecant is going to be these U shapes here. So while this would be the minimum for sine, that's going to be a maximum for cosecant. So once again, if I'm graphing sine and I'm looking for, the u on top of it, which is cosecant, and I'm looking for a minimum, it's going to be where the max of sine is. So once again, we're looking at the quarter period. All right, so let's see. Let's check out our b value here. Ordered pair, no, so we've got our vertical stretch of 3, no shift. So I can already go ahead and tell, that it's going to be 3, because I'm thinking about right here, that's going to be at 3. Like this one was at 2, this will be at 3. And I just want to go to the quarter period. And great news, there's no phase shift here. So I can just see what my period is and go to the quarter period and call this a day. So period is 2 pi over 1/4. That's 8 pi. This is more good news. There's no change in the interval versus the 1 period graph. And so I'm just going to go to the quarter point. And that is 2 pi. So I don't want to take the time to graph that again. Again, you can just look up here and just think about a period of sine. The max is at the quarter, where if you do cosecant, which is that u, that would be its minimum. It's just the amplitude here, and then quarter of that 8 pi. All right, next one. State a rule of a function g whose graph is given by the transformation of f vertically by 2, phase shift. This is pretty easy. All right, so here we go. Stretched by a vertical factor of 2. That goes in front. Cotangent. Doesn't even say anything about the period, so we got no b value. This is going to be t. Phase shift is minus, so this is plus. And add that 5. Okay, so that's pretty easy. Okay, general equation for the asymptotes here. All right, so cotangent. Cotangent has asymptotes at the start and the finish, so there's no shifts here. This is just your parent function. So t, they're going to have those at 0, and they're going to have those. They're going to be at pi, and we got to count for all of them, and so they're going to happen at the start, at the end of the period. And so how do we just keep that going? I don't want to do 0 times n, because that's 0. This is just going to be pi n. Okay, and that n just, keeps cycling it, as cotangent is periodic in nature. Let's see. So secant of 2 pi. All right, so let's just talk about this for a second. So cotangent, cotangent here is cosine over sine, right? This is equal to cosine of t over sine of t. Okay, so, you're looking for where sine is 0, because that's in the denominator, and sine is going to be 0, at the 0 and pi. So that's why the asymptotes pop in. So secant, cosecant here is 1 over sine, right? So this is 1 over sine of t. Okay, so, once again, you've got sine in the denominator. So once again, we're trying to see, where does sine equal 0? Because that's going to be undefined, and that's going to give us our asymptotes. So these guys are going to be the same. Yes, they're going to be the same. Sine is not going to change where it zeroes out. It's going to zero out at 0 and pi. This has sine in the denominator. This has sine in the denominator. So boom, this is also going to be pi n. These are going to work together because they both have the same denominator. All right, now secant is going to be cosine, okay? So this is going to be where the cosine is equal to 0. All right, and the cosine is going to be equal to 0 at pi over 2 and 3 pi over 2. But we have a period shift. Okay, so cosine is going to be 0. So secant's going to have asymptotes where cosine is 0 on a parent graph at the quarter and the 3/4 mark. So I'm just going to get my new period and then see where the quarter mark and the 3/4 marks are, and that'll be the asymptotes for this particular equation. Okay, so period then is 2 pi over 2. So this has a period of pi. Okay, and so those asymptotes for this situation are going to occur at the quarter point. which is pi over 4, and the 3/4 point, which is 3 pi over 4. All right. But these differ, this differs by a pi. So if I just cycle this by pi, one time, pi over 4 will hit 3 pi over 4. So I don't need this in general. Since you have this kind of every other, this differing by pi, this differing by 180, I only need the pi over 4. And I'm going to cycle it. I'm going to cycle it. I can't just do the n here, so I should have spoken to that earlier. Well, I'm just going to cycle it by pi here. Pi over 4 plus pi n. Okay, this one you need to add in the pi. You need to add in the pi. Here, we didn't have to do that because we started at 0. And so here, this occurs every pi. And so to jump from here to here, I have to add in that pi a number of times. So that's a little bit different. This is because it's starting at 0 that you're able to do that. All right. The range of f of x on the interval 0 to 2. And then where is the graph concave up? Interval notation. All right. So range is your y values. So we've got our max of 3. And our min of -3. And, I'm just thinking in terms of cosine right now. So for cosine. Secant, I'm going to think about cosine. And so if I add 5 to that, I've got 8. And if I add 5 to that, I've got 2. All right. And so in terms of now, think about secant. Those are those U shapes on top. So instead of the graph being, waving between 2 and 8, it's going to be on the upper of 8 and the lower of 2. So my range is going to be negative infinity to 2. Oh my goodness. And close up. Let me get my bracket straight. And then 8 to infinity. Okay. So there's the range. All right. So now where are we concave up? Okay. So I'm going to just do a quick 0 to 2 is my interval. Let's just see how that matches up with the period here. So if I have a b value of pi, if you factor that, you got a b value of pi. And if I do 2 pi, period, 2 pi over pi, that's 2. Okay, so good. This is one period. So 0 to 2, I'm just going to be looking at one normal period of this cosine or then this secant. And I do have a phase shift here of negative pi over 4, so I got to deal with that. All right, so let's look at some t values here. If I'm looking at pi x, I guess these aren't t's, these are x's. I'm going from 0 to 2, 1, 1/2, and 3 over 2 right here. Okay, and then let's shift that negative pi over 4. So that's negative pi over 4. Oh, shoot, I didn't factor out this is going to be way better. That was about to be really nasty right there. Let's factor that out. That's, notice I paused because it was about to get really not so fun. And then I realized, so I stopped and I thought, I've probably made a mistake if that was going to be so messy. And I did. I didn't factor out the pi. I was rushing. So pi. And then we factor out the pi here. Divide by pi. This is going to be plus 1/4. Oh, way better. Okay, so this is going to be this negative 1/4. So negative 1/4, 1/4, 3/4. 5 over 4, running out of room here, and 7 over 4. Okay, so now let's think about our cosine graph is going to go. This is a negative cosine graph, so it's going to start low and go high. Okay, and so we're looking for where we are concave up. That's going to be, up here. It's another long problem. That's going to be where we're concave up. It's going to be right there. And that, the asymptotes for, we talked about this right up here. The asymptotes for our our secant occur at the quarter period and the 3/4 periods. So our asymptotes here are going to, oh, you couldn't see that. Our asymptotes here are going to occur at the quarter and the 3/4 mark. So this will be an asymptote, and this will be an asymptote. And so that'll be like so. And that would be this coming through. Okay, so that is between, this line right here is the line we're after. That's going to be in between 1/4 and 5/4. All right, last one here. For the function blah, 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 what are all of these things? All right, amplitude 2. Remember, amplitude is always positive. Phase shift, factor out the 3. All right, factor out the 3. And when I factor out the 3, I'm going to get 4 pi over 3. So divide by 3, right, to factor out that 3. And that'll be 4 pi over 3. All right, so phase shift then is going to be left 4 pi over 3. And period is going to be 2 pi over that 3. And vertical shift is -1. All right, 21 minutes there on page 1. I hope that helps, and I'll start making the second video for page 2. All right, bye everyone.